Hello. In this section, I will do some common limit problems. So we're going to do some basic limit problems you'll probably see quite often. So let's start with example 1. So we got to find the limit as x approaches to 1 of this polynomial. So your goal for limits is not to get anything with infinity over infinity or anything with a 0 on the bottom. That's our goal. So this one's pretty simple because if you just plug in 1 into x, you're going to get a number, right? So that's what I'm going to do. Okay, so we do order of operation and we do the inside parentheses first. So this would be 1 to the 7th is 1. 1 to the 5 is 1 times it by -2 is -2. Plus 1 raise it to the 35th. And so this would be 1 plus 1 is 2, which is -2, so that's 0 raised to the 35th. So 0 raised to the 35th is just going to be 0. Okay. Let's do example 2. So example 2 is very similar to example 1. If we replace x with 2, it would work because you're not going to get infinity over infinity, or you're not going to get the bottom will not get a 0, so that's why it would work. So that's what I'm going to do. I'm going to substitute x with 2. So you do the according to dependence, you do the exponents first. So it's 5, and then replace 2 with 8 plus 4, and then 2 minus 3 is -1. So 8 times 5 is 40 plus 4 over -1. And 40 plus 4 is 44 over -1. So your final answer is -44. So far, simple. You just plug it in, and hopefully you will not get a 0 on the bottom. Now, example 3, there's actually 3 parts, and so part A says we got to find the limit as x approaches 4, and then this is a plus sign. What that plus means, it's 4 to the right. This is an example of a one-sided limit. Okay, and then in part B says we have to find the limit as x approaches 4, and then this is not -4, this is actually +4, but this minus means we're focusing on the left. And part C says, what is the limit as x approaches just regular 4? There's no, notice that there's no plus or minus. So this is definitely a one-sided limit. So what could you do? You could graph it, right? You could graph this and then try to figure out what's the y value as x approaches 4 to the right. Or what you could do is do something from college algebra. It's called this would be what we can use is what's called test point method. So if you don't want to graph it, it's fine. I don't want to graph it, so I will do what's called a test point method. So let's start with A. So let's first find our zeros. So you know how we find our zeros by substituting y for 0, right? So 0 equals 2 minus x minus 4, x plus 2. So when you solve for zeros, your zeros are going to be +4, -2, and then when you set this to 0, 2 minus x equals 0. So for x, I get +2. So these are your zeros. I don't even think we have to worry about the -2, +2. I mean, I don't think we have to test it because our limit is 4. So this is put it on plot number line. So our most positive x value is 4 here. Our next most positive is 2, and then our smallest x value is -2. Right, so we have 1, 2, 3, and 4. I don't think we have to test the areas between 1 and 2 because we only care about 4 to the right and 4 to the left. So I think we're only worrying about boundaries 4 to the right, boundaries 3 and 4. So if our function is f of x equals to 2 minus x, this is x minus 4, x plus 2, right? Let's test, we need to test 4 to the right, so we need to test a number greater than 4. So what can we use as our x value? We could use definitely 5. So it's 2 minus, and then just replace x with 5. So 2 minus 5 is -3. And then 5 minus 4 is 1. 5 plus 2 is 7. So you would get -3/7. Now, remember with test point method, we don't really care about the number, we only care about the sign. So our sign is negative. So that means 4 to the right is actually going to be negative. So this concludes that the limit as x approaches 4 to the right is going to be -infinity. Now, let's do B. 4 to the left. So here, there's 4, there's 2, there's -2, right? 1, 3, 4. So 4 to the left, so that means we only care between boundary 3, right? So if our function is f of x equals to 2 minus x, and we want to test between 4 to the left. So I need a number between 2 and 4. So the best number I can think of is 3. Okay, so on the numerator, 2 minus 3 is -1. 3 minus 4 is -1. 3 plus 2 is 5. So I get -1 over -5, which is positive 1/5. Now, we don't care about the number, we don't care about the sign. 1/5 is positive, so you're going to put a plus here. Okay, so this concludes the limit as x approaches 4 to the left is going to be positive infinity. And then lastly, part C, what is the limit as x approaches 4 of this, of our function? Now this time we don't have to make the line because we just have to look at our previous answers. So for one-sided limit, if this are the same, then it's whatever that number is. But if the limit of this is different from the limit to this, if they're not, then it does not exist. So because there are different values from 4 to the right and 4 to the left, it no longer exists. So it would be D and E. And if they were both the same value, then it would just be that value. Okay, so this is an example involving one-sided limit. Let's do example 4. So the limit as x approaches 1 of x minus 1 over square root of x minus 1. So if you try plugging x into plugging 1 into x, what happens? You get 1 minus 1 and then square root of 1 minus 1. That would be 0 over 0. That is not something you want to have. So what you're going to do is just I'm gonna multiply top and bottom by the conjugate of the denominator. So I'm gonna, yeah, conjugate of denominator. So for example, this would be so I'm gonna multiply here by square root of x, and the conjugate of the denominator is radical x plus 1. Then on the bottom is radical x plus 1. So on the bottom, this is a perfect square, right? So that would be radical x square minus 1 square. On the numerator, I'm just gonna leave it. I will not FOIL it because I feel like something's gonna cancel. So let's just leave it like that. Okay. So on here, radical x squared is just x. Over here, 1 squared is 1, so it's minus 1. So you can rewrite this problem as limit as x approaches 1 of x minus 1 radical x plus 1. And then on the bottom, it's just x minus 1. Okay, so what cancels? The x minus 1 cancels. So you're left with limit as x approaches 1 of radical x plus 1. Okay, then what you could do is just plug in the x value for 1. So this would be square root of 1 plus 1. And we know the square root of 1 is positive 1 plus 1. So your final answer is just going to be 2. You know, example 5, this is what's called a piecewise because there's like 2 equations and then you have different x values. So how would we do this? If you have a piecewise limit or piecewise graph, I would graph it. Let's start. We have 2 graphs right here, right? So let's graph it, and our domain is x from less than equal to 2. So how would that graph look like? So let's graph it here. So first off, what kind of line is this? This is called, they're both linear lines, right? They're like in y equals mx plus b. So yes, let's graph it. Okay, so y equals x minus 1, where x is less than or equal to 3. So we know that the slope is 1 and our b is -1. And what else do we know? Because our limit domain is from x is less than or equal to 3, what if, let's find out what the y value is when x is 3. So do what y of 3, and then that would be 3 minus 1, that would be 2. So when you plug in x to 3 into this function, you get a coordinate of 3, 2. That's important too. So let's plot that point. 3, 2 is right here. And because this is a less than equal, we're going to definitely use, I think we're going to do a solid. So, and yeah, so how do we graph this? This is going to be, so our slope is 1 and our b is -1. So here's -1, and then our slope is +1. So you could go up 1, right 1. Wait, so from here you go up 1, right 1. up one, right one, up one, right one would be this point, and then up one, right one. Now, if you make a straight line like this, we're gonna have to erase. Once you draw the straight line, you're gonna have to erase it again because erase some parts. So our boundary is from x is less than or equal to 3. So that means we only care about this part, right? Because yeah, we only care about this part. We don't care about this part because our domain is from x is less than or equal to 3. So go ahead and erase this part. So you don't need this part anymore. Whoops. Okay, and then we should label it. So it was actually we don't have to label it, we could just leave it like this. Then let's graph the other one, but I think I should use a different color. Let's use green so we don't get confused. So our green, our other graph is y equals 3x minus 7, where the boundary is x is greater than 3. So this is a linear line and our slope is 3 and our b is -7. And where x is greater than 3. So what I should do is first figure out what the y value is when x is 3. So let's do that. So that would be 3 times 3 minus 7. It's 9 minus 7. 9. That's 2. So the point is at 3, 2. So let's plot that point. 3, 2 is right here. I think that we're going to use an open circle, but it doesn't really matter because there's a dark circle overlapping an open circle, right? So it's still going to be a dark circle. And yeah, so let's graph this. So our b is -7, so that means we're going here. Our b, it would be right here. 1, 2, 3, 4, 5, 6. There's -7. And then our slope is 3. So you could go up 3, 1, 2, 3, right 1. And then go up 3 again. 1, 2, 3, right 1. And then from here, you can go from this point, because this is one of our point, go up 3. 1, 2, 3, right 1. So if you draw a straight line, it would look something like this. Now, we have to erase some of the parts because they specifically said our domain is from x is greater than 3. So we only care about this part, right? We don't care about the smaller part because it says x is greater than 3. So what you could do is erase this part. So we don't need it anymore. Oops. So yeah, this is our graph. So let's figure out what is our boundary. So let me hold on. Let me try to find black. Oh, no, I can't find. Okay, hold on. Let's try red. I hope you can see red. So what's the limit as on part A? What's the limit as x approaches 3 to the left? This is not -3. This is 3 to the left. So here's 3. To the left, it's going to be. So what this is saying? What is the y value as x approaches 3 to the left? So here's 3 to the left. It's this point, which is 2. This is going to be 2. And then what's the limit as x approaches 3 to the right? So what they're saying is, what is the y value as x approaches 3 to the right? It's still going to be 2, right? Here's 3. The y value is at 2, right? Because we figured that that was our limit. So it's going to be 2. And then part C is what's the limit as x? What is the limit as x approaches 3, just a regular f of x? Well, this is relating to one-sided limit. So if you look at your previous answers, this is 2, and then this is 2. Now, if they're the same, that's good. That means the limit is just whatever that number is. So in our case, it would be 2. Now, if it was different, it would be D and E. Uh, try to find black. Okay. I can't find black, so we'll just have to use red. So this is an example of using a limit using piecewise function. Okay, so let's move on to example 6. What is the limit as x approaches 2 of this rational function x cubed minus 8 over x minus 2? Well, if you put 2 immediately, what would happen? You would get 2 to the third minus 8 over 2 minus 2. And that would just be 0 over 0, which is not what we want, right? So what we're going to do is simplify. Well, the bottom, well, we can't, I'm not going to multiply top and bottom by a rational number, rational function, or rationalizing the denominator. But what I would do is simplify the numerator. X cubed minus 8 can be factored, right? It can be factored. It is related to the it's related to this this rule. I forgot the rule, the name, but we just got to figure out our A and our B. So our A is going to be X, and our B is going to be 2. Because why 2? Because what number when cubed gives you 8? 2. So once you know your A and your B, just put in this formula. So here, let me write out the formula again. It's A cubed minus B cubed equals to A minus B. And then this is A squared plus AB plus B squared. Okay, so our A value is going to be X, and our B value is going to be 2. So just put it in this formula and you'll be fine. So the numerator will be A minus B, which would be X minus 2. A squared is going to be X squared plus AB, which is 2X, plus B squared, which is 4. Okay, and the bottom is just X minus 2. So what cancels? I see the X minus 2. That's good. You want to cancel as much as you can. So you can rewrite this problem as X approaches 2. And then you're just left with, on the numerator, just left with X squared plus 2X plus 4. And then I'm just going to substitute my X value with 2. So 2 squared is 4 plus 4 plus 4. So that's 8 plus 3. I mean, 8 plus 4, that's 12. So your final answer will be 12. And then I think let's do the last one. So this one is limit as x approaches 0 of this rational function. So it's kind of like number very similar to example 4. So you're going to do the same concept, but the thing is instead of multiplying top and bottom by the conjugate of the denominator, you're going to multiply top and bottom by the conjugate of the numerator. So the numerator, the conjugate of the numerator is square root of x plus 5 plus radical 5, right? It's just the opposite sign. When you think of conjugate, just think of the opposite sign. So do it on the bottom as well. Okay, so on the numerator, it is a perfect square. So it's going to be radical x plus 5 square minus radical 5 square. And on the bottom, let's just leave it as a bottom like that. Just leave it, don't FOIL it out, because I feel like something will cancel. Okay, so let's clean this up. So this would be the limit as x approaches 0. And then when you square this, the radical disappears, so you're just left with x plus 5 minus radical 5 square is just 5. So the bottom is just the same. So when you clean this up, this would be x. 5 minus 5 is 0. And then on the bottom, it's just this. And then what cancels the x. So you can rewrite this problem as x approaches 0. On the numerator, it's just 1. And then on the bottom, it's just square root x plus 5 plus radical 5. And then just plug in x for 0. So this would be 1 over radical 5 plus radical 5, right? And then this simplifies as 1 over radical 5 plus radical 5 is 2 radical 5. If you put that in the calculator, you would get a decimal, which is about 0.22360. So either answer works, this one or the decimal. Okay, so that wraps it up for this section. So I'm going to end the meeting. Okay, thank you. Have a good day. Bye-bye.